Hi everyone and welcome back. Now this little video is going to be about the creating and uploading a pick and place file to the M10V, I think it is, yeah, the M10V mechatronic pick and place machine. So three parts: creating the pick and place file, editing the file itself, the CSV file, and then uploading it and getting those components uploaded onto your machine. I've already shown you how to do it manually on the machine in past videos. If you're doing a if you're doing a big PCB, you know, you've got 100 plus components, or you might have say 5 or 6 components on a very small PCB, but you're doing an entire panel, so that could go up to a couple of hundred components. If you're doing say 5 components of 25 boards, that's over 100 components that you have to place. So doing a pick and place file and automatically uploading all that placement information to your machine makes sense, and this is how you're going to do it. So let's get down onto the desktop right here, and I'll show you how to create a file. And for that I'm going to be using Diptrace. You'll probably be using something different, but the whole process isn't really going to be that much different, even though picking and place files are creating them and uploading them are slightly different. There's no actual standardization, but the general practice is the same. So let's go ahead, and if you have an M10V, then this is how to do it. Alright then, so what I have here is a basic layout that we're going to be picking and placing. Only the components. I'm not bothered with tracks or anything, because this is really about component placement, not about PCB design or anything like that. So when you lay out your board for the MV10, a couple of things that you might want to do. Board outline, obviously. I'll place the origin generally down the bottom left hand corner. It's something that I do as default, and it's best practice. That way, if you've got any screw ups and whatever, you know that the origin is always that point there, so you can align all your different layers and everything all the same. And if you're putting this into the MV10 machine, pick and place machine, the origins are all going to match up when you set the origin to the corner of the board and so on. It does make a bit of sense, makes sense a little bit easier. Not a necessity though. Other things, fiducials, bottom left, top right, I generally use crosses for that, since that the fiducials on the MV10, when you're placing it, it's a crosshair, so you can align the crosshairs to a cross centrally a lot easier than a little circle or dot or square or something like that. So that's that. Single arrow just for me, just to say that that's the top of the board, because I haven't really got any tracks or anything coming down. I'll probably forget which way up that bloody ball goes when we come to place it in the machine, so that's just for my reference. Right then, moving on, things you need to do with your layout. As you can see, you've got my components placed down, and if we either double click on component, you can open up component properties, or right click and go into properties in Diptrace. Opens up the components dialog box. You want to add in a few extra values that aren't added or need to be altered for picking and placing. First one is the value of your component. As you can see, I've typed this in as a 1K-1%-0.125 watt resistor. It's an 0805 package. That value is critical. That has to match your component part in the pick and place machine. So in your pick and place machine, if you've only denoted a 1K resistor as being 1K, then it will be 1K in your pick and place machine. If it was say 1K 1%, then it'll be 1K 1%, and so on. It is case sensitive, it is white space sensitive, it is little dashes and wibbly wobbly bits sensitive. So whatever component that is in your pick and place machine that you programmed in and you set in your library, that is the value that you type in there. If you put in any other value in there, when you upload this to your pick and place machine, it won't find the component in the machine, and that component will not get placed, it will get completely ignored. So that is a critical value. Value is critical. That's got to be the same as machine. The other thing that you've got to enter, it's not critical, it's not necessarily necessary, but it does make life a lot easier, and that's your pattern. Your pattern is basically your package type. So in your pick and place machine in your library, you might have, in my case, I've got lab reels / 0805 resistors, and the height of my resistor is 0.5 millimeters, half millimeter thick. So that is where my 1K is now found in my pick and place library on the M10V. I always keep that the same. I like to keep it the same simply because I know where to find the component. So when I upload this file to my pick and place machine and I'm setting the packages, I know exactly that that component value is in that library. If you don't know what libraries that your values are in, or you haven't set them, make sure that you do set that to, change it to a reasonable value. So it's sort of like resistor 0805, capacitor 0603 or something like that, on SOIC 8, whatever. And yeah, something obvious that you can identify, and you know that when you look in the library on the MV10, you can match it. That's all down to matching. But if you know where your components are, you know what they are, where they are, what they are, then try and keep it same, because it does make life easier when it comes to uploading the file to your machine. So they're the two things. Value is critical. It's got to be the same as what's programmed in your machine. Pattern, ideally keep it the same, but make it intuitive so you can find it. So they're the things that you've got set, and as you can see, I have, if I double click on that one, I've set these up for all my components, and there we go. So pattern SOIC 8, and it's a UA741. That's how programmed in the machine. So that's what you got to do for all your components on here. And as you can see, for this little test board, I've actually rotated some of these around. So this is angle 0 degrees. This one is at 90 degrees. R3 is at 90, and so on. So if you do a little test run like this, you know that your components are going to be placed, orientated around the right way. That your library matches your PCB package. Once you've got that all sorted out, go up to File, down to Export, and no brainer, no biggie, not rocket science, pick and place. You want to export a pick and place file. Diptrace is simple, gives you loads of different output options, and one of them is pick and place. That's why I tend to use this program. It's very intuitive. So then, pick and place report dialog box opens up, and a couple of things that you want to set. Because I've already done pick and place in Diptrace, this is already all set up for what I need for the M10V. So if you take a look at this, this is how you want your layout to be in your pick and place file. This is basically how to export a table of values, really, that the machine can understand. So first things first, component coordinates should always be set by, not the component origin, it should be set by the center. Ooh, I lied. Okay, component coordinates set by the center of the component. Generally, all pick and place components are always picked up and programmed into the machine via the center. So therefore, you want to pick up your components and have your layout match that, so you have some sort of standardization. Everything's done to the center. And if you take a look, you can actually see the assembly data here. All your little crosses on all your components, they're all centered. So yeah, go to the center all the time. Next thing down, columns. You want to set up, this is the important stuff. This is what the meat of the machine actually digests. Okay, so you want your reference description, your ref des, pattern, value, X position of your component, or Y position of component, in other words, the center of your value component where you want to place them, the rotation data, and which side of the PCB you're using. I always use the top side or the bottom side only, never both for surface mount components. Surface mount picking and placing, you do it top and bottom side, you're in for a world of pain. Quite frankly, you know, you can be placing components on the top of your board. When you flip it over to place components on the bottom side of your board, if you haven't reflowed it, then you can start firing components off the bottom side of the board because you're hitting the dot side, making it bounce. Heavyweight components will drop off when it goes through reflowing. Components on the underside will probably tombstone. The surface tension is all out of whack, and weights and sensors, gravity and everything pull the components in the wrong direction or pull them to tombstone, and just drop off the board altogether. So you have to start worrying about bloody surface mount DC and stuff like that. So, you know, when it comes to side, I only ever really worked on one side or the other. You're probably different. It's up to you. It depends on your process. To set these up, basically you set the line. You say either add, delete, and what have you, so you can edit what the line is, and you can change what the line actually denotes. You only need to do 7 different values. You do not need to know the width and heights or the names, the generic naming component. What you need to know is the other stuff. So just just slowly add them in. Ref des, pattern, value, X, Y, rotate and side. Next down, setting the layout of your table. No biggie, no critical thing. Just make sure that you tick the box to add headers so you know what the columns mean when you start importing data into your pick and place machine. Always useful. Next thing down, offset. Use design origin. I always tick that one on because I always use my design origin as the bottom left. The machine's design origin is the bottom left, so you might as well use design origin to be bottom left because it's always bottom left. You don't need to think about anything else. Like I said, set that as bottom left as your default set standard. You can't go wrong. Once all that is set, you know, just make a mental note that everything is in, obviously, millimeters, and export the file. When you export the file, export it to a memory stick so you can get it into your pick and place machine computer, unless this is where you're doing it, obviously. I'm going to be bringing up with this file elsewhere, so we want to save it as, I normally save it as pick and place file. You could do it as a whatever else, you know, board name, what you know. And when you save this, you save it as a CSV, so you can open it up in a text document or a text, sort of like a notepad software or anything like that. Any text reader software or Excel spreadsheet software that you want. Hit save. Comma separated file, column divider. So how it divides out your tables. Yeah, it's a comma. Comma separated CSV. It's going to be a comma. Obvious. Okay. Done. So that is your pick and place file generated onto your memory stick, and there it is. So we'll open up this, double click on this, it will open up in Excel for me, and there we go. No, let's shut down my lab schedule. You don't need to worry about that. All right then. So this is our pick and place file. So we've got reference, description, pattern, value, X, Y, rotated side. All our descriptive values down here, pattern sizes, you know, all the different pattern types, component types, so on, so on, so on. Doesn't really matter about justification in held, doesn't matter about fonts or all that sort of stuff. When you, well, click on that. When you open up this file, first thing that you want to do, make sure that everything is populated. There should be no blank spaces. If there's a blank space, this is where you can edit your CSV file, add in the extra information. Notice something has been entered wrong, like these diodes. If that was meant to be, say, 1N4148, then that's where you can edit it in there, or you can go back to your PCB program, back into Diptrace, edit that component value, and then re-export again, get it all back in. So just have a general check over this. Make sure there's no blank spaces. If there are, something's gone wrong. Make sure your patterns are correct. Make sure all your values are in the right layout. Once you've done that, you might want to edit your column titles. I do that just as a course of, it's what I do to match the machine, so I know what I'm putting in the machine is the same. And if I use a profile that's already predefined on the machine, it does save a bit of time because everything conforms to a set standard. So I normally set that to ref, that one to, whoops, I'm typing that the wrong way around. Package, value is value, X, I'm going to do it X, Y is Y, rotate becomes rotation, and side is side. Resave that, yeah, use the same format, I'm going to keep it as a CSV, and we're done, and that is editing your CSV file. You might want to keep, if your columns aren't in that order, you might want to make them into the same order. If you try and keep your layout same for every single pick and place file that you do, you'll have no problems whatsoever uploading this to the machine. So just follow the general conformity, reference package value, X, Y, rotation, side, make sure everything's filled in, job done. Right, and let's upload this to the machine and show you how to import it, and yeah. Alright then, back at the machine. That's my little PCB I got made up, so that can go into the pick and place machine, into the rails, usual place, just like how I told you to set up in the previous videos. Reels have been set up, so yeah, a couple of components in the machine. So you want to set your board up, set the components in, teach them all in and what you're not before you do anything else. Once that's done, we'll start uploading the stuff, which is what we'll do now. Right, and so first things first, you got all your board in the machine, you got your components loaded into the machine, you want to set up your board, so set, usual stuff, teaching your circuit. I have to apologise for the not doing a screen capture on this because I haven't got screen capture software on this computer, what's on the MV10 unfortunately. So yeah, we'll have to make do as is. Hopefully you can see what's going on. Set the board origin. That's done. Next, teaching the surface. And there we go. Done. So XY origin coordinates and PCB top surface answer topology is done. Next, training your fiducials. As I mentioned before, I always tend to use crosses because lining up is a little bit easier. As you notice, I've got a few little holes in this board. Those got whacked in just to align the mask on the panel when this board was made, because I didn't have any holes or anything on here to align anything to. So just setting the fiducials, bottom left as usual, top right. As you can see, crosses do make life a bloody lot easier when you're picking and placing. Right, so board has been taught in. Next, program. This is the meat of it. Go to program and you want to right click, select import generic CSV file. As you can see, this is our importer where it imports our table. Built-in functions, reference package value, X, Y, rotation and side, which is all the information that we exported, your units, whether you're working on the top layer, bottom layer, etc., and which one you want to import. So, first things first, import file. At the top, this is saved on my memory stick, so there it is, PP file. Open, as you can see, reference package value, X, Y, rotation side. Reference package value, X, Y, rotation side, it all conforms, it all matches, makes life a lot easier. So you have to try and match this table here with the table what the machine uses. So CSV header, just click on these little boxes and select the various things. So ref is ref, package, value, center X is X, center Y is Y. One moment. It'll go off in a second. Oh, thank God for that. Right, and that was just a compressor for the pick and place machine kicking in. So as I was saying, ref to ref, package to package, value to value, X to X, Y to Y, rotation to rotation, whoops, Y to Y, and side to side. There you go, made a little mistake there, but having the same headers to built-in headers definitely does highlight when you make a problem. Units was in millimeters, so we select millimeters. Everything's on the top side, so we want to import layer at the top, and reference designators, top is top, bottom is bottom. Hit next. Oh yes, yeah. Right then, this is where I was saying about making sure that your packages matches what's in the machine. So just expand that out. So import, just like we did with the table headers, do the same sort of thing, only this time we're working within the library. So double clicking on the little box underscore which is headed Mechatronica opens up the library, and you just want to match the components to the library. So lab reels, 0805 resistor, 0805 resistor is right there. Okay. As you can see, it's populated those ones. They're no longer red, slowly going black as you add them in. So this one is, next one was the SOIC 8. So SO8-16, SO8-16, there it is. Okay, this one is the SOD123s, which are my diodes, I believe. Yeah, there they are. So SOD23 diodes. Okay, and my transistors, same thing. There they are. Okay, so if you keep them the same, trying to find them in the library definitely does make sense, and as you populate them, when they're correctly populated, they do, drop in. Everything's okay. So next thing is aligning your components to the board. And the way how it does that is you align the first component, you align the last component. So I think it's bottom left, top right how it does it. So it does it to the extremes of your board. It looks at the XY data. It says, right, that's the one bottom left, that's the one top right, and we'll use that offset. So basically it works out an offset, and then it applies it to all the other components to map in where they go on your board. So first component is R1, 1K resistor in that position. You will right click and map to target position. I believe my 1K is that one. Is it bottom left or top? I can't think. Or is it top left? It might be top left, bottom right. It does it to the extremes anyway of the board. So, it does corners to corner. this is where having a silk screen on your board does help. I've just knocked this one out on the quick, so I'm hoping I'm placing these in the right places. Should have done a printout really. Never mind. Yep, so that's my R1. So just drop it onto the board. If it's in the reasonable position, it will turn. As you can see, the XY date hasn't changed. And this is my diode. 2, I think. Is it that one or was it that one? It may have been that one. Now, I'm using a slightly different package for my diode. It's not an 0805 which are used in the PCB layout. It's actually a DO123, so it's slightly bigger, but it does fit on my pads. No, it's not that one because it's at 90 degrees. brain. That's a bit of a brain fart moment. It's not that one, is it? It's D2 is that one. It was D2, that one. Hold on, I'll be back in a moment. Right, I'm back. Yeah, brain fart moment. It is that one, and obviously it is that one because I've only got 2 diodes on this board, and this one is set to bloody 90 degrees, and it's the only one that is at 90 degrees on my design, so smack to the head. So yep, that one's placed on the board in the right position. Okay it. So those are in the right position, R1 and D2. Next, time profile has changed. Do you want to save it? Yes, we do. So save your profile. Let's call it Pick Place, whatever. I'll save it on my memory stick with the other one and save. Goes back to the program. As you can see, everything's been added in, and the XY coordinates have all been set to the right position. And as you can see, rotational data has changed by points of a degree. So the board was reasonably square already, but as you can see, it does make slight amendments to the data for where you place that component. If you're happy with everything there, you can single step. You can do your check-in and what have you of your component layout. So say U1, just show that component. Is it in the right position? Hey, look at that, it's in the right position. So you might want to go through the list just to make sure that the components are in the right places for you place. And if you're happy, click run. And it slowly goes down the list. Oh, it's having a bit of problem picking up my 741 there. Let's have a look. What's the problem with this? Yeah, looks like that my heights are slightly out on that component. Right, I'll just ignore that because this is just a quick little demo. There we go, a little bit of a screw up on the 741, so where I just hadn't set the height, it wasn't bringing the nozzle down low enough to actually pick up that component. So I skipped over those ones. But as you can see, yep, it ran through the program perfectly fine. If we just go mobile for a second, you can see here, components have been placed. Seems to be okay. Now, some of them have shifted a little bit, but it's not bad. They're shifted because there's nothing actually on this board. I can tap that board and yeah, you can see them jumping all over the place there. So yeah, so that's how you import a pick and place file into the MV10.
Any questions on that, let me know. It's just a quick basic run through. Hopefully you can see what I was doing on the screen. And as usual, when you do your test run, if you do get any components which haven't been placed, then you can go back into your feeders and yeah, just adjust that height or the position. Yeah, anyways, I will leave it there, and yeah, that's how you upload into a machine. That bloody compressor, I need to get a new one.